All right, so for today's video, we're going to continue with our discussion of one-dimensional motion. Today we're going to talk about instantaneous, average, and constant velocity. All right, so hopefully by the end of this video, given any two of the following variables, you'll be able to find the third. So we'll be working with displacement time and average velocity. You should understand the difference between instantaneous and average velocity. And you should understand that if an object has a constant velocity, then the terms velocity, instantaneous velocity, and average velocity are all interchangeable. Okay, so here we go. All right, so for the first thing we need to talk about is what's called speed. I don't know that I'm going to make this into rocket science. You all know what speed is because you are all either getting or have your driver's license. You know that if you're speeding, it's because you're going too fast, and that is because speed is a measure of how fast an object is moving at one moment in time. All right, this is important. All right, usually when we use the word speed, we're referring technically to what's called instantaneous speed. Okay, and you're measuring how fast the object is moving at that instant. All right. And you know that, if you're talking about a car, you would measure your speed in miles per hour, right? Because the faster you're going, the more miles you will go per hour, right? We will end up using meters per second instead of miles per hour, but same idea, all right? Now, you know that when you drive around in a car that your speed is always changing, and that is going to complicate things for us. So for right now, we're going to keep things simple. Sorry about the bell there. We're going to keep things simple. And so to do that, rather than talking about instantaneous speed, we're going to begin by learning about what's called average speed. All right, and average speed is exactly that. It measures the average distance that an object travels per unit time. Emphasis here on the word average. Okay, so if I say that my average speed is 60 miles per hour, that does not mean I went 60 miles every hour. It means that I averaged 60 miles an hour. All right, so a simple example would be if I drove 300 miles to Chicago in 5 hours, then I'm going to get an average of 60 miles per hour, right? That doesn't mean that I drove 60 miles every hour. It just means that I averaged 60 miles an hour. It might be that I drove 70 miles in the first hour because I was eager to get there, but then maybe I had to stop and get a taco or something, so I stopped for a half an hour, but I averaged, during my trip, I averaged 60 miles per hour. Okay, so notice the symbol that we're going to use for average speed is just S average. Sometimes you'll see people put an S with a line over it, and the line indicates average. I will occasionally slip into that by mistake. I'm trying to get used to writing out average, but if I write the S with the line over it, that's what I mean. All right, now, honestly, I probably won't, because in the same way that we don't usually care about distance in this class, we don't usually care about speed. What we really care about is what's called velocity, all right? The reason I talk about speed is because velocity is very, very similar to speed, all right? But here's the big difference. Velocity measures how fast an object is moving in a certain direction, okay? So speed doesn't have anything to do with direction, and thus it is a scalar, whereas velocity includes direction, and as a result, it is a vector. Okay? So, if we're talking about motion upward, your velocity could be positive if you're moving up at a certain speed, and your velocity would be negative if you're moving down at a certain speed. Okay? So, velocity, again, usually when we say velocity, we're referring to instantaneous velocity. It measures how fast the object is moving in a certain direction at one moment, again, okay, because we're talking about instantaneous. All right? Now, again, the fact that the velocity can change, the fact that the object might speed up or slow down or whatever, makes things complicated. So we're actually going to begin by talking about average velocity, all right? And average velocity, you can probably, I don't know, maybe guess what it is. I'll just tell you. Instead of measuring the average distance that the object travels per unit time, it measures the average displacement that an object travels per unit time. Okay? So very similar, but we focus instead of on distance per unit time, just displacement per unit time. All right, so a couple things to note about this, and then we'll do some examples. First of all, velocity and average velocity can be negative because they're vectors, right? Notice, and this, I didn't write this down, the only way that your average velocity is negative is if your displacement's negative, right? Because you can't have negative time. Okay? Let's see, what else? Speed is always positive because it's a scalar, so it doesn't have direction. Okay? If an object's velocity is constant, then the velocity is equal to the average velocity, right? Like if you legitimately drive to Chicago and you have the cruise control set at 60 miles an hour, then your average speed is going to be 60 miles an hour. And at any given instant, your speedometer is going to say 60 miles an hour, so your speed and your average speed are the same, okay? The same is true of velocity, okay? So if you don't speed up or slow down or turn, which we'll talk about that later on, but as long as your velocity is constant, then your velocity and your average velocity are the same, all right? And finally, for now, most of the problems that we're going to deal with are going to be constant velocity problems, all right? Until we learn about how to deal with changing velocity, okay? So, examples, I already ran through this one. The big difference here, I guess, is that it's looking for average velocity. So I am going to run through this. I want to model problem solving, all right? Here is the expectation. When you're solving problems in my class, from now on, the first thing you need to do is write out your givens. Now, you don't need to actually write out the word given, but here's what we know. It says Roy drove his car 300 miles west. Oh, that's telling me how far he went and the direction. So it's giving me a displacement. 300 miles, and then the fact that it's west means that it's negative, right? Because north, south, east, west, in math class, this direction is negative, right? So I'm going to make that negative. And it tells us that he does that in 5 hours, and we're looking for his average velocity. Okay? So right now this is a little bit silly because we've really only got one equation, but by the end of this chapter we're going to have, I don't know, 8 equations. Taking the time to do this is the hardest part of the problem, I promise you. Once you get this part done, the rest of the problem will be easy. Particularly for most of my honors students, I tend to find that's the case. This is the hard part, all right? So, once you've got this, pick an equation. So for us, there's only one equation right now because it's whatever, day 2 of this class, displacement over time, and plug in your numbers. And you go, oh, well, he went 300 miles to the west in a time of 5 hours. So his average velocity is actually negative 60 miles per hour. All right, and I guess if you really wanted to, you could do one of these, miles per hour. All right, I'm going to try to get in the habit of writing that, although I tend to be sloppy. Okay, so there we go. All right, let's see, this one. Roy jogs at 3 meters a second for 12 seconds. All right, so let's see. So it's telling me how fast he's going. It doesn't say anything about direction, so I'm going to assume he's moving in a positive direction. If I wanted to, I could call this speed, but we're going to, 99.9% of the time, we're going to talk in terms of velocity. Thus, I'm going to label this as velocity. So his velocity is 3 meters a second for a time of 12 seconds. Now, here's another assumption that we're going to make. It says that he's jogging at this velocity for this amount of time, right? Which implies that for this entire amount of time, this is his velocity. And so it looks like this is constant, right? It looks like he's not speeding up or slowing down or anything. So I can call this my average velocity, right? Okay, and then it wants to know how far he goes, so it's asking for displacement. Okay, so a little bit of algebra. I know that V average is displacement over time. So multiplying both sides of this equation by time tells me that displacement is average velocity times time. All right, this equation will come up often enough that you might as well just memorize it. And hopefully it makes some common sense. This is just basically distance equals rate times time from your algebra class in whatever grade that was. All right, so our displacement is, well, let's see, we're going 12 meters per second. No, we're not. Sorry, I lied. We're going 3 meters per second. So every second we're going 3 meters for 12 seconds. Notice dimensional analysis, units, the seconds cancel, and we get 36, and the units are meters. Okay, so hopefully that makes some sort of intuitive sense, right? Because it's just a rate. Okay, all right, and then finally, we'll learn about acceleration in the next video. I thought I had one more example. Real quick, let me just add in one last thing, and then I'll shut up here. I see people make this mistake all the time. Check it out. Try again. If you're solving for time, you got to be careful. V average is displacement over time, right? So suppose I told you that, a car was moving at, I don't know, 8 meters a second. So maybe that's your V average. And maybe we want to know how much time it's going to take for the car to go a displacement of, I don't know, 120 meters. All right. So some of you are like, oh, you divide. Yes, sure. But I always see people make a mistake on this. So to do the algebra on this, if you want to solve this for t, multiply both sides by t to get the t out of the bottom of the fraction. So in other words, start with this, and then now we divide both sides by v average to get that t is displacement over v average. I see people do this algebra wrong all the time. So if you're looking for time, this is the equation you should use. All right, we're going 120 meters at a rate of 8 meters a second. So divide that out and it gives you, what is that, 15 meters, I think. All right, my math might be wrong there, but yeah. Okay, so there we go. Cool. Sorry, I lied. One other real quick thing. I jumped back to example number 1 here. I went back and looked at the learning targets and realized there was one thing I didn't talk about here, the difference between average and instantaneous velocity. So in this example, it says, Roy drove his car 300 miles to Chicago in 5 hours. We found his average velocity. Turns out to be 60 miles an hour, right? Suppose I asked you what his velocity was when he crossed this, the city line. That would be asking for instantaneous velocity, right? Because I'd be asking for the velocity at one specific instant, all right? And there's not enough information for us to find that here, right? All we can find is his average. Given this information, that's in this problem, there's no way for us to find the instantaneous velocity at any given point. Okay, we will learn how to do that in the next week or so. Well, actually, when we begin acceleration, we'll learn how to do that. All right, so there we go.